Thank you very much, Arjan, and welcome everybody to this year's digital edition of FLEXCON, which we have the great pleasure to be co-organizing again between FAN, and Bert is going to say a few words in a moment, and Smarten, Smarten being the European Business Association for demand-side flexibility. And I'm really glad that we are able to repeat FLEXCON this year, even if in a different fashion. And I'd like to thank all the supporters, all the sponsors, and especially you, the participants, of being here and being committed to making this work. And I would already thank Adrian, Mikael, Leila, and the team who've been, and Alicia, who've been involved in setting this up and making it work. We have an interesting program ahead of us. Today, starting with the kickoff of FLEXCON on e-mobility, smart charging, and vehicles to grid. And I hope you've earmarked the following Wednesdays in your calendars, because we'll go on with sessions from now on every Wednesday for the coming weeks on a different theme. So really looking forward to the coming weeks and the coming sessions, and in particular, of course, of today's first kickoff. Before we go into that, though, I would like to hand over to Bert, who will welcome us all on behalf of FAN.
Well, thank you, Frauke, and many thanks for doing this with Smarten again. Smarten being the master, I could say, in flexibility on the policy side. We, as a Flexible Power Alliance network, come a little bit from the technical side, but together we always manage to organize a good conference. Of course, with the thanks to Adrian and his team. Flexibility is now needed more than ever. Where we're going to a Europe that is going for a higher percentage of renewables and carbon dioxide reduction in 2030, and to a climate neutral 2050, where in this new energy supply, flexibility is needed for everyone. The grid can use flexibility to avoid investments, and no doubt Elia will talk about that, James. Perhaps they will even rely on flexibility. I don't know. We will hear about it. The consumer can also profit from that, which we will hear hopefully from Elaad and others. And the market can profit from it. So here is my statement. Flexibility is not something to be added. It is not a luxury. It will become a necessity. And I hope we go into that with a fresh mind. We are active as FAN also now in European standardization, so there's much to come. And I hope to hear from the panelists how they will look on developing this market in the best possible way. Adrian.
Yes. Thank you. I think the word is for Frauke, because she will be the moderator of this session, and she will also do the rest of the introductions. Frauke, the floor is yours.
Yes. Thank you very much, Adrian. And while I'm talking, you will already see on the screen our first quick poll. You will see a couple of polls throughout the events. We clearly invite you to participate in order to help us get an impression and involve you also directly. Of course, there are other options to be involved, and you saw the slides at the beginning. You will see it again. Please use the chat box to post questions, and we will try to come back to all of them if time allows us. So yeah, please don't hesitate to post questions already while the presentations happen, and of course, especially also during the Q&A session. So first here, an impression of who we have in the webinar. Seems to be a very good representation of different elements. Wow, I wouldn't have expected such an even representation. All between 21 and 26% on the different elements. So that makes, I think, for an interesting discussion later. But well, before we go there, let's get started with our keynote for today. I assume that you've seen the program. We're starting with our keynote presentation from Elia today. James Matthys-Donnadieu is going to talk about delivering the energy transition thanks to flexibility from everywhere in the system. James is currently head of market development at Elia, Belgium. I'm sure everybody knows Elia as the TSO in Belgium and also important parts of Germany. And yeah, I think, James, you've been with Elia for quite some time now in this, especially from the smart energy perspective, crucial role. But interesting to point out also that you have experience on the market side. Before joining the TSO, you worked as COO of the APX group and CEO of Belpex in Belgium and the Northwest Europe region. So again, coming to your keynote on delivering the energy transition thanks to flexibility from everywhere, and the floor is yours.
Thank you, Frauke. Good afternoon to everyone. Before I start, I was indeed the CEO at Belpex, but the COO at APX. And why is that important? Because my colleague back then was Bert Denade. So I had the pleasure and the privilege to work side by side with Bert at APX, and obviously I have learned a lot from Bert. So that had to be said. Going into the slides, if I may see the slides. I don't see the slides on the screen.
They're loading.
Do you hear me? They're loading. All right. Okay. So yes, thank you. And I will, so if that works as well, I should be able to move the slide. So as said by Frauke, Elia is part of Elia Group. So we are one of the top 5 TSOs in Europe. You can look at the numbers which are on the slides. I don't know if I'm in control of the slides or if someone else is. I don't think I am in control. Okay, because I'm pushing and nothing is happening.
Try to move. Are you moving?
Maybe it's better that you keep control at your side.
We control. You control.
Okay. Talking about flexibility, I just recycled this slide from 2016. No, one slide back, please. Just recycled this slide from 2016 just to illustrate that Elia has not waited 2020 to look at flexibility as well as its potential. Can I go back one slide? Thank you. So this is a slide from 2016. Back then already we had identified that the context was changing rapidly. More renewables, decentralized generation, digitalization was upcoming, and obviously also the European network codes. we did assess that the impact on Elia was that we would need more flexibility to operate the system. And what's very important here is when I talk as a TSO about flexibility, I'm more talking about balancing the system and not so much in terms of congestion management or avoiding network investments. I think that if you would ask the question to DSOs, he may have a different look at flexibility, and obviously flexibility can be an answer to several problems or an opportunity for several challenges. So the context was changing. We saw impacts on Elia, and back then already we knew that we had to find answers. Well, the first answer, of course, is when you need additional flexibility in the system is to ensure that what you have to procure as a TSO remains as low as possible, and this is because we need to keep our tariffs as low as possible. So every megawatt that you don't have to procure is the cheapest megawatt, of course, and we have done so by enforcing the role of market parties and also moving, and I think we're still the first in Europe, the only one in Europe to do so, moving to what we call a dynamic way of dimensioning our means based on artificial intelligence. This is an algorithm run daily. And on the other hand side, when we have to cover our needs, we need to do this in the most efficient way. So we have implemented reserve sharing. We are working hard in integrating balancing markets. We have moved to short-term procurement, and we know this is very important also for demand-side management to participate to balancing markets. All our products will be in a daily procurement mode as of, well, the last one will move into daily procurement on the September the 28th of this year. And then last but not least, we have opened all our markets to all technologies, all players and all voltage levels. So at least in theory, all the products of Elia are completely technology neutral and independent of the voltage levels. When it comes to accessibility to our products from the lower voltage, from the residential levels, there, of course, there are also still some requirements or sometimes some barriers on DSO side on which we have to continue to work. So that was anno 2016. I would say that by today, or at least by next year, when Mari and Picasso will be live, we will have achieved this roadmap. So I think we've come a long way. This being said, and next slide, please. Is it coming or? Yes. Well, we all know this lady, and we also know that she has great ambition, and we fully support her ambition to move towards a carbon neutral system, which means, and then if we move to the next slide. If we implement the ambition of Mrs. von der Leyen, and we do support that, we are also convinced that the system will have to change fundamentally. We there talking about some kind of a paradigm shift where in the old days and still today to a certain extent, generation is following consumption. Well, once most of the thermal generation, if not all, will be replaced by renewables, we will have to move to a world where demand will have to follow generation. And so the center of gravity of the energy system will have to shift from, I would say, the more traditional utilities towards decentralized, towards what I would call more the prosumer. And that's important, at least we recognize that this shift is necessary. And so we have to work on the necessary elements to make that shift happen. If we move to the next slide. I mean, everybody is talking about flexibility. We at Elia, we have tried, first of all, to put a definition on it, and secondly, we have also tried to quantify it. You know, when we talk about adequacy, and now I'm saying adequacy for on purpose, adequacy basically is making sure that in your system you have enough capacity to cover your peak demand at any point in time. When we talk about flexibility, it's all about having the right quality of megawatts in your system so that you can cope with variations in the system at any point in time. And those variations, well, are definitely caused by fluctuations in demand, can be caused by forced outages, but obviously are also caused by intermittent renewables and all the forecast errors that come along with that. And following from that, we have tried to define or to put a certain taxonomy on flexibility, and we have come to, and this is of course our definition: slow flexibility, fast flexibility, and ramping flexibility. And you can see that definition on the slide. And then we have developed a model in which we try to quantify how much of those different kinds of flexibility are needed in the system in order for us to keep the lights on. And I'm really talking from a system perspective. I'm not talking from how much shall we procure in terms of ancillary systems, really from a system perspective, how much of this flexibility and those different quality of flexibility is needed so that basically the system remains manageable. And as you can see, this is based on Monte Carlo simulations. I mean, you have all the details written in extenso in our adequacy and flexibility study for Belgium 2020-2030, which is published on our website, and we will update the study every 2 years. So in addition to adequacy, we have been looking at what the flexibility needs are in the future. And as you can see, towards 2030, our flexibility needs, whether we talk ramping flexibility, slow flexibility, or fast flexibility, the flexibility needs of the system will increase substantially. And basically, this biggest increase is due to the increase in offshore wind that we will have in Belgium, and all the prediction errors that come along with offshore. So we have an increased, from a system perspective, we have an increased need in flexibility. If we move to the next slide. Yeah, this slide is a little bit more complicated, but basically, and I think the slides will be circulated afterwards, we have also looked at where is this flexibility, or where will this flexibility come from? And what we have figured out is, certainly when we talk about fast flexibility, in terms of availability in the system, I'm not saying whether it's present or not, but in terms of availability in the system at any point in time to deal with system variations. For instance, when you look at the orange line here, fast flexibility will be made up mostly by non-thermal capacity. And also, if you make the link between this graph and the previous graph, you can see that 2,400 megawatts, which is more or less the amount of fast flexibility that we need in the system on the 99.9% confidence interval, there will at any point in time not always be enough flexibility in the system available, so we need to think of other mechanisms to encourage flexibility to make itself available in order to help us keep the lights on as a system operator. Next slide, please. So I have said that obviously the generation mix will dramatically change. That will cause a paradigm shift, and in that paradigm shift, what is clear is that the consumer, or better to say the prosumer, will be in the center. So we need this consumer/prosumer to play with us and to become an active player in the market. That's one very important element. The other important element is that we also have to recognize that the consumer is changing, and there is no uniform definition of what a consumer is, what his needs are, what he wants, and everything else. So on the one hand side, the system will change, and on the other hand side, the consumer will change. He will, and this brings us basically to what we call, or yes, now you can move to the next slide, to the need to go towards a new vision for the system, which we call a consumer-centric vision. A consumer-centric vision, which shall be organized around, I would say, three main building blocks. On the one hand side, there's a real-time communication layer, which is necessary to exchange in real time all system relevant data, but also all other data which are necessary to, I would say, support the development of all kinds of services for the end consumer. Obviously, we will need a lot of new digital tools, and not only as a system operator, but also I would say the commercial parties will have to develop also a lot of new digital tools. But, and that's obviously also where our role comes into play, we believe we also need an upgraded market design. When you look at the market design today, I would call it that this is quite a supplier-oriented market design. As an end consumer, you do not have a lot of degrees of freedom. I have listed five things that today as an end consumer you cannot do. Today, the amount of contracts at disposable is quite limited as an end consumer. Today, as an end consumer, you cannot engage into peer-to-peer trading. Today, as an end consumer, you would not be able to exchange or to appoint a service provider or a different service provider per appliance. Linked to that, it's very difficult in the current market design or in the current market arrangements to develop or to engage in contracts which would be more energy as a service, especially on appliance level. And also today, well, yet we have the guarantees of origin, but there is no point-to-point link possible between, I would say, a consumer and the originator of, well, call it green power or any type of power. So those are 5 categories of things which we believe, if you want to engage the consumer, if you want to make it for the consumer interesting, either passively or actively, yeah, because energy as a service is basically a system where the consumer does not have to do anything. You know, he's just buying a car, and it may be that the insurance, the maintenance, and the energy comes along with it, provided, of course, that that someone can operate all this for him. But that's also consumer centric, because it is about the comfort that the consumer wants. All the 5 motives I've listed here on the slide are not possible today. We take it as our challenge as market facilitator, TSO market facilitator, to think about how we can redesign the market in order to make this happen in the future. We've gone quite a long way in our thinking. I cannot say more about it yet today, but we think we have some ideas. So hopefully in the next couple of months we will be able to communicate more about it. But that's definitely the goal. If we want to engage the consumer, we need the consumer in the future. We have to recognize the consumer is not a unique animal, and that he will have, and also his behavior will change because of digitalization. We need to, if we want to be able to engage him, we need to make sure that all those different degrees of freedom are offered to him. So we call our consumer-centric vision, we call this also sometimes the Internet of Energy. And in order to test with and to engage basically with market parties to make this happen, we have created an ecosystem. If we move to the next slide, that will be very quick. Yes, we have created an ecosystem, so we are engaging with a lot of market parties out there. We call it gigawatt partners or megawatt partners, depending on how much interaction we have and how much they are engaged. And amongst all those different parties, we have set up so far 8 pilot projects, and this is also the last slide. 8 pilot projects in which we are testing ideas. I will not describe what each of the pilot projects is doing. We have a dedicated website for this, which is describing the different pilot projects. And there shall soon be also, because we are now almost 1 year, we set it up almost 1 year ago, so we will soon be able also to communicate the first results, and hopefully to announce also a second phase of testing and a second phase of setting up pilot projects in order to make or to somehow to speeden up the developments and the thinking around this this consumer-centric vision. Can move to the last slide. Yeah, so those are the 8 pilot projects which we are involved in, not always as a leader, often it's also market parties, and all the details of it, you can find that on the URL, which is in the middle of this slides. So I just added those 2 slides to say that we are not only talking, we are also trying to do in an as innovative and as interactive way as possible. Next slide. voila, that was the end of my presentation, but undoubtedly exciting times ahead of us. Thank you.
Thank you very much, James. And I like the huge wave coming there, and at the same time, quite a refreshing perspective to see or hear you as TSO talking about these massive changes, this big wave coming as an opportunity, much more than a threat that we would have to prevent. So yeah, much appreciated perspective. I had prepared a couple of questions to dive a bit deeper. Seeing though that the time is already quite advanced, I suggest that we dive right into some of the audience questions for the discussion, because I see there are some really interesting ones coming in already. So let's give the audience a chance already, if that's okay with you, James.
Sure. I don't see the questions from the audience, so someone will have to.
I will read them out to you, because the first question is, does the 2030 figure for increased demand-side flexibility require any regulatory changes, or are your forecasts based on the present conditions, present market conditions, regulatory conditions?
Well, the needs expressed are needs from a system perspective. So this is a technical approach. Obviously, what we also know is that if we want to have enough flexibility by 2030, we need to change or at least amend the current market design. And indeed, we may need regulatory changes to move to what I would today call a more supplier-centric market design towards a truly consumer-centric market design. So yes, there regulatory changes may be needed, but it's hard to identify yet. I think that the clean energy package is going a long way in setting the objectives. I don't think that the clean energy package is also setting out the way how it shall be done. And obviously, this is now up to us as a market facilitator if we want to be relevant also in the future to come up with proposals to test together with market parties so to make it happen.
Great, thank you. Then we have another question, quite a specific. Can you clarify what you mean with contracting service providers PER appliance that you had on one of your slides?
Whoa, that's very detailed. And which slide was that?
Slide 9, maybe we can have that displayed. Yeah, there we go.
Contracting different services. Oh, that means that it should be possible to appoint a different supplier or service provider if you are under an energy as a service contract for your heat pump, and yet a different one for your car. And why not also selling your the energy of your solar panels to someone else while having your base load taken up by, for instance, your regular supplier? That's what I mean by appointing a different service provider per appliance. It should be meaningful, of course, and not for an iPhone. You're not going to appoint a different supplier, but there are some appliances that do consume and that have some flexibility that may be worth isolating and having optimized by someone else.
Thank you. Very interesting and very important clarification. I guess this idea alone could merit an entire session. Yet I'm already moving on to the next question, which is, how is your vision related to the Equigi platform that was presented by Tenet and a couple of other TSOs?
I think there are some very interesting ideas in the Equigi platform. We are studying it with a lot of interest on group level, by the way, not only Elia Belgium, but also Elia Germany. I cannot say more at this stage, but we are obviously looking at it with great interest, because I mean, some of the elements which we also would need in this, I would say, this future market design could be facilitated by Equigi, but there is more around. So I cannot say more about it at this stage, sorry.
Good. And coming already to the final question that I think we have time for here. What is the importance of real-time smart metering data and non-intrusive load monitoring of individual appliances on the residential level in your perspective?
Whoa, that's also a specific question. Well, I mean, the more data are available, and of everything should be GDPR proof and so on, of course. But I mean, the more data are available, the more services can be offered on top of that. If someone is hiding everything, or if something which is happening inside the house is hidden, it will be very difficult for service providers, you know, to valorize the flexibility to optimize assets over time from day ahead to the real time. So there is an opportunity, I would say, for consumers to find the right balance and to share their data with people out there, again in full respect of GDPR, because that can only lead to better service offerings.
Okay, thank you very much, and once again, thanks for the very forward-looking and I think positively accepting viewpoint you gave us, James. You can see in the audience there is already the next poll launched that should help us also. Well, it's I think a very important question following on to James's presentation, and based on what you heard, what is the biggest driver for Flex? And while you're responding, I already lead over to our next presentation, which is by Arjan Wargers from ElaadNL on smart charging and energy flexibility behind the meter protocol. So Arjan is really looking at open standards and protocols for unlocking flexibility for the in-home and the building domain. And Arjan is manager at research and innovation at ElaadNL Netherlands, and also an innovator at Nexus. Arjan has been with ElaadNL since 2010, so for 10 years now. And before handing over to you, Arjan, just a quick view at the polling results. Can we have them displayed again so people can get an idea where we are?
Yes, my apologies, I was a little bit too fast. Maybe I can share it with you in text because I cannot share the screen at this moment. So 90% of the people think that e-mobility is a driving force. 36% think that wind and solar generation is the driving force. 26% thinks good working flex trading markets are very important for the flexibility question. Enabling technologies like IoT and blockchain, only 4% thinks that, and 15% thinks congestion challenges are the main driver for flexibility.
Thank you very much, Adrian, and thanks to all of you for the responses. Again, quite a mixed response. I'm very interested to see that we have a very wide spread here of perception as to what are the most important drivers. I guess it goes to show that all of these elements really matter in the system. But now, handing over to Arjan. I already introduced you, so the floor is yours, Arjan Wargers.
Great, thank you for that. Good afternoon. Can you hear me and see the screen?
Yes, we hear you well and see it.
All right. So indeed, I'm with Elaad, and Elaad is an organization which was founded by DSOs, the Dutch DSOs, 10 years ago, to foster e-mobility. We started out as a charge point operator, so we installed charging infrastructure throughout the Netherlands, and we changed over time to a knowledge organization for electric mobility and smart charging in particular, focusing on the smooth integration of e-mobility into the grids. And last period, we dove into the in-home domain, into the built environment, to see what is technically possible to extract flexibility from the EV and other flexible devices from within the in-home domain. And we did that, this is my introduction and the agenda. We did that because of the conclusion we draw from our outlooks that like 3/4 of e-mobility, 3/4 part of the EVs will be charging in on the in-home terrain. And as such, the charger itself is behind the meter, and then you can then there are different ways how to connect to the EV to extract the flexibility. But next to the EV, you have multiple devices, and it would be like a shame not to include the heat pump, the solar panels, and so forth as well. So we dove into that terrain, and we did an exploration on protocols on how to extract this flexibility from these devices. And from our perspective, we discovered a few more things than just a plain exploration, a plain survey on what kind of protocols you can use. And this is what I wanted to share with you this afternoon. So we're looking at this domain. In the middle, you have the energy management system, or sometimes the SEM, the customer energy management. And this system is connected to different flexible devices in home from which you can extract flexibility. To pinpoint what we investigated, it is the in-home situation. So outside, you have the TSO, DSO, and the balance responsible parties with all their challenges and as such different needs for flexibility. But we are focusing on how the EMS system connects with different devices. And for that, we chose to focus on what we have called the energy management system model. So the operator model is more or less what we've been focusing on regarding charge infrastructure in public domain to extract flexibility from the CPO backend system, so to speak. You could also extract flexibility from the EV through the EV itself, through the OEM itself. And the EMS model is then focused on like a central system within the home, which is connected to all flexible devices and can provide the flexibility to the request of the flexibility. But again, like the Elia presentation, the customer is centric. The customer is in charge. So the customer decides what his preferences are to provide this flexibility. And in this chain, the customer is in charge. You have flexible devices. You have the EMS system trying to unlock the flexibility from the devices, and you have the energy stakeholder who is in need of this flexibility. And this chain needs to be connected, and we try to focus on the interface between the flexible device and the EMS. Then again, in the concept of energy flexibility, we need to go through a few steps to decide what kind of energy can be provided to the energy stakeholders who are in need of this flexibility. This is important to notice. So this is important of the concept of the context of energy flexibility. Device integrity, user comfort, and then also user integrity. In the final step, the user decides for itself how much flexibility it can provide. Of course, there's pricing mechanisms to incentivize customers and other mechanisms, but as such, it's the customer itself who's in charge of that. And beneath, more or less, that we need to make it technically available that the flexibility can be extracted. And then when we look at the concept of energy flexibility, we thought it was wise to abstract the functions, what we are talking about. So when we're looking at flexibility and as such diving into different protocols to extract this flexibility, it's easier to map the protocols on the main functions for extracting the flexibility. And that is registration. So a device needs to be acknowledged or registered to extract flexibility from. Energy flow reservation. So the device has to make clear what kind of energy need it has for itself. Metering for validation, and then adjust capacity. That's like the core of energy flexibility, but these other functions need also be taken into account, otherwise the flexible device cannot be addressed. And what is also very good in our perspective addition is to recognize device types, or to see what kind of devices there are, not in terms of the exact device, but what kind of flexibility it can need, it can deliver. So we have the functions and the device types, and that together makes the connection of these flexible devices to EMS, and also the language, what kind of messages from the EMS to the flexible device do we have to exchange. That makes it easier. When following this inquiry or this survey on what different protocols are there to extract flexibility, we came across two different approaches, which we think is worthwhile to mention. So we have the direct approach, this is what we've called, and the indirect approach. In this direct approach, when we started this exploration, we thought it was the only approach how to extract flexibility from a device to the EMS. We thought there is a direct link between the energy management system and the flexible device, and that there more or less would be the discussion, would there be one single protocol, or would there be multiple protocols which the EMS has then to support. The other approach is like what we've called the indirect approach. This is also an approach which is used for the European standardization of the in-home flexibility protocols, which is now going on within ElaadNL. And in this approach, there is like a software representative of the flexible device, which is called the resource manager. And the software application is the point where the EMS talks to. And this makes it somewhat easier to standardize the in-home interoperability situation, considering the fact that there are already quite a lot of protocols available to extract this flexibility. The resource manager is like a piece of software representing the flexible device, and EMS can talk to this resource manager, and the resource manager can talk then within its native language to the flexible device. And in this way, it's more like interoperability of existing protocols than a totally new protocol, which will then be added on top of the existing protocols which are used in the in-home domain. And of course, you can then architectural wise place this resource manager on different places. And this is more or less up to the implementation, but this is also considering the fact that flexible devices are getting more and more connected. The resource manager in the cloud environment of the flexible device management system would also be a good suggestion to place this software representative of the the flexible device. So within this indirect approach, there are still different possibilities to place this resource manager. And I want to highlight these two approaches because this like makes a difference on what we should be focusing on for extracting flexibility. This table is actually the core of what we started out with. So we looked at different protocols, we looked at the pros and cons, and we like developed this table based on openness, interoperability, and maturity. We like scored different solutions, and this has a lot more details to it than what just this table says. But the origin of the different protocols is also different. So it was quite hard to compare different protocols with each other. Doing this, coming back to the previous situation, we found out that this indirect approach with this resource manager is also the core of European standardization. We didn't know this when we started this exploration, but this is something to focus on in our perspective. But what we also did, when you look at this standardization work for this indirect approach, that is something which is going on now, which is studied, and we'll probably have a standardized solution for that by the beginning of next year. But in the meantime, in practice, there is a lot of work going on already based on more or less not plug and play interoperability, but connecting different devices through Modbus and through an API. So the standardization work is one thing, but practice is still on another level, and we need to combine these two. So when we look at the total situation we investigated, we see that there are several open existing protocols. And on protocols, they already exist, and they are mostly suitable for unlocking flexibility. And it is expected that the interface specification to the resource manager will be provided in the beginning of next year. And then we see that unlocking flexibility at this moment in time is not always the main focus of the manufacturers of these flexible devices. So there are a lot of challenges still to overcome. And coming back to the bottom point on the sheet, having a standard does not mean this like immediately works in practice. So we need to develop a feasibility study to investigate the practicalities of this indirect approach using a resource manager. So when conducting this study, we came to a few recommendations, some recommendations, and a few of them I would like to pinpoint in the last minutes of this presentation, which is coordination. When we would follow a siloed approach, like an approach for the heat pumps, an approach for charge infrastructure, home batteries, and so forth, that could lead to longer times to integrate all these aspects in the total home. So that was our first recommendation. We need like coordination on how to bring all these devices together. And the second one, I pinpointed that before, is like feasibility studies of this indirect approach. we think this indirect approach is very promising because you overcome like partly the discussion on which protocol to choose, because like every flexible device can keep on more or less talking their own protocol, and then the resource manager can then talk to the EMS through the standardized protocol. So the flexible device manufacturers, which are already working on other aspects than only energy flexibility, they can stick with their own protocol, their own development as such. And we could also start with brand-specific protocols and then go slowly from the flexible device side to a standardized solution. Other recommendations are to align the attributes. What I mean with that is there is a lot of use being made of Modbus to do the extraction of flexibility. When we align the different attributes, like the heat pump uses the same, every brand of heat pumps uses the same registers to address the extraction of flexibility, then we are making a step already. API development is also a step which can be made on a relatively short term. And using a basic set of functions per device type. So when you come back to the function description and the device categories, when we make this, like when we make a simplification for that, we could already develop this chain between the EMS, the resource manager, and the different flexible devices. What's also a good one is to further assess the flexibility device, the suitability of it for unlocking flexibility. And last but not least, take into account cybersecurity, especially when we are going to do these feasibility studies and we are using this approach with an API. Cybersecurity is coming more and more important to prevent infringement. I had 15 minutes. I think I really almost kept it within this 15 minutes. And now, like, open for your questions.
Thank you very much, Arjan. Yes, almost 15 minutes,
Yeah.
A bit more, but it leaves us a little bit of time still for the questions. First of all, thanks a lot. I think in FLEXCON, we've always been trying to push the frontiers and move into new areas, and you certainly have by looking at the in-home flexibility and the appliances there. And we already have a lot of questions coming in. I'm not sure if we will be able to cover all of them, but let's get started and see where we get. And the first one is potentially expensive EMS required for residential flexibility, or can individual product suppliers integrate connectivity in products? And in this case, the question is, can they integrate it directly with TSO and DSOs? I think that's another question I would park here. Let's keep it to the first part. Can they integrate connectivity?
Yes, they can. If I understood the question right, is it possible to have a direct link between the flexibility requested, being it a TSO or a DSO, and a flexible device? I think that's possible. But when you do that, and then you're getting a system or an architecture where every device a customer decides it's suitable to registers to a TSO or a DSO or what kind of flex program ever. And I think you're missing out on opportunities when you're not doing this through an energy management system. The system costs money, but it can better balance the flexibility possibilities you have within your home, and then match that with the requesters. So I think it can, and that's a question on what's the cost versus the pros. It is possible, but then I would also say we need to assess the flexibility potential of different appliances in home. When we see that every appliance can have its contribution, or quite a lot of appliances can add to the flexibility needs of the stakeholders involved, then it's worthwhile to develop an EMS. When it's only one or two, you can think of separate registration. But for now, we think following this energy management system route is quite a good approach.
Okay, thanks for this. Another question is that the continuous interaction with the consumer would unlock higher flexibility capacity, of course, in comparison with the static approach with the consumer. But at the same time, there's the risk that the consumer simply gets tired of the continuous interaction on what their wishes are. What do you think is the right compromise, and how is it done in practice according to your protocol?
Yeah, that's a very good question. When we when we look at this situation that the customer is in charge, I think the customer should be in charge of entering threshold values, like I want it to be in my home always 20 degrees, or my car should be charged until 80% on 8 o'clock in the morning. That is something which should be possible with EMS solutions, and then the EMS connects with the different devices to see what kind of flexibility it can provide, and then within the threshold of this consumer. So I think that's also the one of the key competitive edges of EMS devices or integrators, how to make that available to the customer, that without a lot of hassle, he or she can enter his threshold values, and then the system works for itself within these thresholds.
Okay, thank you very much. There are lots more questions. I will take one more, and for all the others, we will collect them. We will pass your questions to the speakers and try if we can work with them from here on onwards. But one more question we can take, and that is, should the European Union try to make open protocol mandatory? What do you think?
Yes.
That was a short answer.
Yeah, no, of course. Open protocols has a lot of advantages. It means it opens up competition. It makes sure that a customer has still freedom of choice for an appliance or an EMS without shifting all the flexible devices. So it provides customer choice, and it comes back to the customer-centric approach, which we saw in an earlier presentation. So I think the openness of the protocol should be mandatory, mandatory pinpointing one single protocol and one single solution. That might be too early. We need to gain some practical experiences, and so yes to the question, should openness be mandatory? Yes. Should be pinpoint one single protocol, one single solution? It's too early for that yet.
Okay, thank you very much, Arjan. I find it very strange in online events, great as they are and well as they work, we can't applaud you. I already thought that after the keynote we had from James, so a virtual applause also to you. Thank you very much. before we move over to our next presentation, a quick glimpse at the most recent polls. Do you think in-home interoperability needs better cooperation, and who needs to be involved? Well, definitely more cooperation is needed, and you've identified regulators, governments, manufacturers, and aggregators as the main players here. So on that note, let's move over right away into our next presentation on vehicle-to-grid, specifically on an innovation project that aims to pilot testing the possibilities and capabilities of, in this particular case, of delivering FCR, so frequency containment reserves from parked electric vehicles. And Thijs Vral and Jelle Meersmans are going to present on this project that has basically looked into a comparison between unidirectional and bidirectional charging of electric vehicles. A short word on our speakers. So Thijs is part of the Elia innovation team, where he is taking a leading role on projects related to electromobility. And Jelle Meersmans is coming from Enervalis, where he is product manager. And Jelle has held different roles in the energy field before in consultancy, retail, technology. And both of them will, as two of the partners in this V2G project, give us an overview. So the floor is over to the two of you.
Thank you very much for this kind introduction. I hope you can hear me. So indeed, as been said, I'm Thijs. I work at the Elia Group in the innovation department, and I'm here together with Jelle from Enervalis, who's a product manager over there. And together, about 3 years ago by now, we have started a project. Well, I was not there yet, but Jelle was there. Jelle started a project with a former colleague of mine at Elia on vehicle-to-grid and FCR, and we will explain you what we did and what were the main outcomes of this project. But before going too much into the details, first you will be able to see that at Elia Group we are really fond of our main policy makers. So if you can go to the next slide, you see again Ms. Ursula von der Leyen, whom we all apparently see as our main person to look up to when we were talking about innovation and about where we need to go. And so, as you probably all know by now, the European Commission has decided that Europe should become the first climate neutral continent of the world. And this has mainly has consequences for the power industry and for the automotive industry. And this is why we are actually, since a couple of years already, talking about integrating electric vehicles into our grid, into the power world. We will see, I will show in the next slide that EVs are scaling up, but before, sorry, Jelle, one back, because I will show that EVs are scaling up, but before going there, this quote is remarkable because it's been made not so long ago at the beginning of the pandemic that is hitting us right now. And you might, or you could have thought that such pandemic would have stopped some ambitious goals like the European Green Deal. But quite on the contrary, as this quote clearly shows, it's not the case. Actually, on the other hand, we want to ramp up, and we see the pandemic as really a way to start recovering from this pandemic and to go further together and to grow stronger, which has a consequence on us, of course. So if we now go to the next slide, you will see that we do expect a big ramp up of what is currently still, at least in Belgium, a niche market, to become a really mass market in Belgium, in Germany, and in Europe. For instance, we see that there's three main reasons, or we believe that there's three main reasons for this ramp up. That is, first, we see more and more availability on the market of commercial and interesting electric vehicles. Secondly, we see, as we saw in the previous slide, policymakers really shifting and pushing the society towards clean mobility. And thirdly, we also see bottom up from the society an increased pressure of moving towards this clean mobility. And so these three elements together really show us that towards 2030, 2040, the ramp up of this currently niche market is really gonna take place. And this has consequences for us as a TSO in Belgium and in a part of Germany. So on the next slide, you will see that if we calculate in 2030, these are numbers for 2030, if we calculate that in Belgium there's going to be 1 million electric vehicles, so this is the left figure, or 10 million in Germany, this is the right figure, we estimate about 10% increase in our grid load in the evening peak. Which means that if we don't do anything as being the system operator in these two countries, we will have to probably ramp up, well, not us, but the market, the system will have to ramp up some fast starting, for instance, gas turbines. Expensive power will have to be supplied for about 1 hour to charge these electric vehicles. So we see quite a threat. We see that this might become challenging for us, or at least bring us to an undesired situation. For this reason, we actually want to turn this threat into an opportunity. And so the next slide just easily or nicely shows that, as you all know, everyone attending this event, an EV is basically a battery, and many EVs is basically a massive battery that can provide flexibility to the system. And this is actually where we started a couple of years ago, as James has already explained. And so a couple of years ago, we decided to start a project to look at how can we turn these opportunities really into into concrete business value for our company. Next slide, I'm going to show what this concretely could mean. It's just a very, very high level case. How could an EV become a battery on wheels that provides flexibility to our system? As you can see here, we can imagine a case in which during the day an electric vehicle is parked at work, which of course today is maybe not an everyday situation anymore, but still during the day we could consume the solar PV energy that is produced at work. The car could drive home at the evening, maybe during the evening peak when in a new grid tariff design, the power might be the most expensive. So during this time, we might supply energy from the battery to the house to cook, to clean, to whatever. Then maybe the next time slot we will want to charge the battery to a certain level of state of charge to make sure we can get to work the next day. And then we can use the rest of the night to provide flexibility services or other services to the market. Here it's shown that for maybe 4 hours during an FCR time slot, frequency containment reserve is provided to the market. And then maybe from 4 to 8, imbalance AFRR, whichever is the most lucrative at this moment, could be the choice of the system, of the energy management system. And so then we decided to make this a bit more concrete, and we started focusing on FCR. So if you go to the next slide, and I will then hand over to Jelle. We really started, we looked for partners. The partners are here indicated on the bottom of the slide. EV Consult, Enervalis, of which Jelle is here, and New Motion, which is a well-known CPO and based in the Netherlands. And together with those partners, we really started looking into how can we now actually start putting these EVs into our network and get value out of it. So with this, Jelle, the floor is yours.
Yeah, okay, thanks a lot, Thijs. Go more into the details of the project itself, the things we executed. So I first wanted to explain a bit what the difference is and the impact on also state of charge of the car when you provide FCR services with unidirectional or bidirectional charging. So you see the graph there on the left. So with V1G, actually, you cannot discharge the battery. So that means, in essence, that state of charge cannot decrease during a charging session. But if you want to deliver FCR with unidirectional charging, you must be able to, at the same time, decrease the load, but also increase the load So in practice, that means that you have to modulate the session in a completely different way, and you have to maximize the time that the car is actually charging, because when it's already charged, that means, of course, there's no flexibility available anymore. So that means that the car, so the state of charge curve will evolve much slower than if you compare it, of course, to dumb charging. And with V2G, of course, there the difference is you do not need to actually charge or discharge to be able to deliver, or let's say the state of charge does not necessarily need to increase during the charging session to be able to deliver FCR, because you can also discharge the battery. The reason also why we wanted to analyze V1G for FCR, because FCR is a quite known use case for V2G, is that we do not know, of course, whether V2G will have a proper uptake in the next coming years, for example, because there's still a lot to do linked to the infrastructure side. And the interesting part about being able to deliver FCR with unidirectional charging is that you basically do not need additional hardware investments. You can use what's already available, so that the charging infrastructure network there, so no additional capex investment costs to enable that service. The problem is with V1G compared to V2G, and that's linked to the protocols that are in use, is that you do not have state of charge information when you apply V1G, except, of course, if you can access the data from the car itself through the OEM. But normally it's not available, so that complicates the situation for the aggregator, because you need to forecast a lot about state of charge, what you estimate that it is, and what its energy demand will be for that given session and user. And another positive side effect of V1G is, of course, like Thijs explained or showed on the impacts on the system, is as you modulate the session in a completely different way, you actually decrease the system peaks as well. So it has also a net positive effect on adequacy for the TSO. So what was a bit the setup? So as mentioned, we had also NewMotion as partners. So they have the CPO and the MSP role. So they operate the charging network and therefore provide the communication with the charger themselves. So the V1G, so the normal charging stations, and then we had 2 V2G chargers in the project. They also developed a new module into their backend, which is called the ESM, the Energy Services module, which provides the communication with Enervalis, which is mainly OCPI based with some modifications that were necessary for these use cases. So in essence, Enervalis does not directly control the charging stations. It all passes through CPO backend. They provide us the meter values, so to get us insights of the status of the different chargers, and then based on different types of inputs like the frequency measurement, we compute the set points to be able to deliver FCR with a pool of EVs. So technical setup, so we had a V2G charger at the office of Elia, the headquarters in Brussels, and we also deployed one at the home location of an Elia employee, where we also integrated it with an EMS system, actually similar like Arjan just explained previously. Then secondly, also NewMotion developed a new kind of app, so for the interface with the user, so that he could indicate his settings, so his comfort settings, but that would also allow him to overrule a smart charging session. So first part of the project was to analyze the individual behavior of charging sessions. So we started there from predefined assumptions, and we performed a series of tests, quite a lot, I think more than hundreds, to really identify the behavior of the sessions. So things we assumed and that we covered in these different tests was, so first of all, the response time. So FCR imposes some strict regulation linked to response time. So we wanted to check there how fast the EV could respond to a power command coming from Enervalis. And so also how much time it took to arrive at the power value itself. So difference between when we saw response and when it arrived at the power value. Another thing we needed to analyze was the predictability of the response. So meaning, for example, if we send a certain power command, is that exact power command also executed? So what is the output then given a certain command? Because you assume there that when you send a power command that it's the exact value that is also executed, but we will see afterwards that that's not really or not necessarily the case, and that has a lot of implications linked to how you develop these algorithms. Another thing also that we wanted to test was whether we could use the full, let's say, power range of the charging session. So going from 0 to maximum power that car was able to accept, because that has also a lot of implications on the amount of FCR capacity you can bid into in the market. So going to some conclusions, we saw that response time of unidirectional charging is a bit slower than with V2G, but that full activation time, as product requirement is 30 seconds, was achievable with both V1G and V2G. But that we also saw that we had slow response times with downward regulation. So being when we increase the power of the session. Another thing we saw linked to predictability is that we saw irregular responses between certain bandwidths of amps. So that has also impact on dispatching algorithms, so which set points you can send. That was specifically for V1G, whereas with V2G, it actually executes exactly what you send to the charger. Availability of the power range. So perhaps people that are in the field, they know that not necessarily all cars accept 0 amp commands, meaning they go then into a sleeping mode, and then you lose actually the flexibility of that session. So that has also a lot of impacts on how you dispatch such a pool. And also we saw some differences in response times depending on the values that we send to the chargers. So as FCR is quite a strict regulated product, that means we had to create a whole onboarding flow for chargers, because we have to learn all these different parameters for each individual car and charger combination. So to give you some insights, said that with V2G, it executes what you send, and that's clearly what you see also on these graphs. And that actually has to do with the fact that you do not need to pass through the inverter also of the car, because you're working on the DC side, so you have direct communication with the BMS. And perhaps another reason is that also you use a different protocol. That was not further investigated, because that's what we assume that is the reason also for that. And then for V1G, as I said, you have when you send power commands, it's not necessarily the same value that is also then executed. So that meant that we had to develop a new model, so to train actually commands versus responses for each car charger combination, because for FCR delivery, it's the response that counts, it's not the commands that you send. So you have to know which commands you need to send to be able to have a certain response of your pool. So second phase was that we needed to implement the whole FCR algorithm for a pool, because first part was focused on session level. So we developed a lot of things that we learned through the first phase as well of the project, but we already had a lot of this stuff linked to also already pools of batteries that we manage as an aggregator. So first part on the left side is, let's say, everything on pool level that is done before a gate closure time. So if you want to send in FCR bits, you need to inform how much power you are able to deliver, and then link that to a certain price you want to capture. So we use flexibility forecasts there on pool level, and also planning optimization linked to the revenues linked to 4-hour blocks. And that results then in a bit that is sent to the TSO, typically to Regelleistung platform. We then receive a confirmation, so what the result was, and that then translates to a plan that must be executed for certain 4-hour blocks. Then we have what we call an overseer, so we will look at all the available charging sessions on pool level, with also the frequency as an input, and that translates then to a certain command for a specific session, where we again use flexibility forecasts and that command response model that was needed to be developed. So here are some insights on tests we did linked to full activation. For example, we started with a smaller pool in the beginning, so we did not arrive at 1 megawatt because there basically were not enough chargers in the pool in Belgium. But over the project, we actually also added chargers of the Netherlands into the pool. So in the end, we were capable of arriving at 1 megawatt. So these were a bit kind of a smaller pool. You can see the response here for a typical full activation test. The problem, of course, you have with EV sessions is that you can always have new sessions that start, and that will, of course, impact your response quality. And so you have to then also integrate a lot of feedback into your algorithms to be able to respond to those sudden start or stops of sessions that can impact your response quality. And sometimes, of course, they do not react as you want them to do. So your algorithm really has to be able to adapt quite fast, and that has also a lot of impact on the CPO backend because latency is very important for this use case. Here you see this was actually after the project itself, when we enlarged the pool and we further fine-tuned the algorithm. So basically now it's capable of delivering megawatts of FCR with, in this case it was V1G, and the response is actually quite well and according to the specs of the TSO. We also made then an analysis with Elia on the requirements of FCR and the status at that point in time linked to the V1G and the V2G. This part is specifically for V1G, because for V2G actually it qualifies everything, but V1G is a lot more difficult in that sense. The things that are in orange linked to response times, that is partly due because we had not enough of charging sessions to deliver 1 megawatt at that point in time. And then the impact of having new sessions started really impacts your response quality. But we saw when we enlarged the pool that you do not have that amount of impact when you really have a large pool available. So the other.
Sorry, to interrupt, just to flag that we have 5 more minutes, including questions.
Okay, I will skip this one. I will just mention the conclusions. So FCR delivery with V1G, it appears to be extremely complex. We didn't anticipated that, and it also requires a specific onboarding process. Another important thing to mention is because the ecosystem is quite complex with the CPO also in the middle, that it also impacts the CPO backends because you really need to reduce the latency as much as possible. And these backends were never designed for these use cases. They were designed for billing purposes, so they didn't need real-time meter value for that. With V2G, it's not extremely complex. It's similar like a pool of stationary batteries. But in order to have it become mainstream, you also need to have the OEM involved, because the end user wants to have it validated by the OEM that when you deliver such services, it doesn't impact battery warranty. And then we also did analysis on revenues, how much cars we need, etc. It's not a lot for V1G because it's a symmetrical product and you need a lot of charging sessions also to be able to deliver that. And delivering AF4R with unidirectional chargers, that promises much higher revenues. Just lastly, give the word to Thijs for a closing remark.
I will probably skip this slide, but just to say that we are with Elia Group launching a new publication on e-mobility. We're organizing an event on 20 November where we will take this actually this story much further with the whole company. So if you are interested in joining this event, contact me via LinkedIn. But voila, please, very happy to answer all the questions.
Great. Thank you very much, Thijs and Jelle. And before we go into questions, and we already have lots coming in, I think that Arjan has another poll for us. While you are responding to this question, just also to inform you that we've had participation of up to 80% to the poll so far, which I think is something I've never seen in an event. So well done to you. And we have quite a large audience actually. So well done to you for really remaining active and engaged in this. Yeah, when do you think V2G will really gain momentum? And while we're still waiting for the response to display, just also to reassure everyone that of course the slides will be made available after the session. We're also recording the event for looking back into it, but for sure to respond to all your questions, yes, the slides will be made available. And there we go. In 4 years, that seems to be the not only the vote with the most outcomes, but also the peak of the bell curve. So 4 years it is. So now you know what you have to deliver at scale, Jelle and Thijs. In the meantime, a couple of questions. There's really lots that have come in. First, maybe two that I can group for clarification. One question was, how big was the pool of cars that you were managing in the project? And then also another clarification question, can you clarify if for V1G, you need to couple it with additional assets to offer symmetric FCR?
Yeah. So currently it's around 15,000 chargers that we have in our pool. And the way how we develop the algorithm, we do not need additional assets. We can just deliver it with just EVs.
To clarify that answer, I think it's important to understand the FCR delivery is not necessarily a zero asset that can go up and go down, but we measure the FCR that is delivered to our grid based on the baseline. So we actually look what did the asset do before and where is it now after that we asked the FCR delivery. So we don't need elements to go up and go down. We just need the baseline to go. So if you have a car that is charging at 10 kilowatts and you go to 5 kilowatts, this is actually delivering 5 kilowatt of FCR.
Okay, thank you. I see that many questions were about latency and so on. You've already come to those throughout the presentations. They should be answered. A technical question here. Since CHAdeMO is diminishing compared to CCS, what are the chances of DC V2G compared to AC V2G?
That's a good question. So you have in the CCS roadmap, it's included in there to be able to support V2G. was set at 2025, but they're accelerating that. The problem is, of course, with DC charging, there you have a lot upside cost linked to the charging infrastructure. So personally, I don't think that's the way to go. If you look at it from a system perspective, the lowest cost you can achieve bidirectional services is when you standardize the AC side, because the upside costs for the OEM are very limited, and on the other side you can standardize the charging infrastructure. So that has a lot more potential if you want to untap the potential of V2G. That's my opinion there. And if you do it with AC, then you do not need CHAdeMO or CCS. You just do have your other protocols for AC charging.
Thanks. Maybe one more question. In V2G, do you sell back the energy fed back to the grid at the same price you bought it, so including network tariff, taxes, and levies?
The use case here was FCR. The problem is if you do price arbitrage, and typically EVs are at distribution grids, you have the double taxation of grid tariffs, so it kills your business case if you do price arbitrage. That's a problem there. It's in the clean energy package. Normally it should be tackled by each member state to provide a solution there. But in the meantime, price arbitrage, given the double taxation of grid tariffs, it kills your business case.
And I think filling on to that answer, I think James has hinted towards a new market design that is under development and that should arrive in the future. And I think this kind of questions are really to be tackled by such new market design, because clearly, as you correctly state, the current market design would not be fit for such purposes.
Okay. Thank you very much. Again, lots more questions. We will pass them on to the speakers, certainly for information and where we can manage for further treatment. So once again, thanks a lot. Virtual applause to Jelle and Thijs. And thanks a lot for the very engaged audience. Stay on, because we have our next presentation now. Rolf Bienert from OpenADR is going to talk about DER control strategies and EV charging. Obviously, the more we're looking into smaller resources, the more important standards-based approaches become. And Rolf is going to talk about standard-based approaches, in particular also a case study on the integration of EV charging infrastructure as a fast-growing field. Just a word about Rolf. So Rolf is the Managing and Technical Director of the OpenADR Alliance, and is also present in various associations and organizations driving the development of new technologies, especially through standardization. Before moving into this field, Rolf was working for a global testing field, always in the technical standardization firm, sorry, not field, global testing firm, always in the technical standardization area. Now, without further ado, Rolf, the floor is yours, and good morning on your side of the ocean.
That is right. Yes, thank you, Frauke. Yeah, it's just about getting light outside now, so feels a little more like day. And I suppose typically at this time we would say, hey, only half an hour to the reception, right, and the open bar. So so hopefully at the next event we can say that again. Just to confirm, you can see my slide, right?
Yes, we can.
Perfect, super. Then let me hop right in here. So thanks again for having me here from still sunny California. Lucky a little less smoky these days, but definitely we had some interesting times here with the wildfires, and bad air quality. You might have seen the images. I should have put one in this presentation, come to think of it. But anyways, very strange skies here over the last few weeks with smoke buildup in the upper atmosphere and so on. And certainly a lot of focus was also on the utilities here because you never know how fires are starting, whether it is due to some personal choice or basically power lines touching trees and so on and so forth. So again, demand side management and flexibility certainly came up quite a bit again this summer as well, because we had long stretches of very high temperatures, in fact up to like 45 degrees Celsius, which is not very common here, even during the summer. This is more Death Valley and Arizona temperatures. Anyhow, that being said, let's hop right in. I'm going to give you a little overview of OpenADR, and then we talk a little bit about these control strategies that we have seen here, and really also that are still under discussions here, and then leading into a few of the programs that are already in place about EV charging and things like that. So in a nutshell, for those of you that may not know, OpenADR is an open standard for demand response. It's not new. It has been, the development has started in 2001, 2002, after the energy crisis here in California, where we had rolling blackouts and brownouts. And the Energy Commission at the time said we do need an automated way of communicating with these resources out there. So OpenADR works with web services. It goes through existing internet typically, although sometimes it can also use dedicated connections like cellular modems and things like that, in particular if the resources are far out there. But in general, we use broadband and communicate either through an aggregator, as you can see here on the right, or directly to the resources via gateways, or in some instances even directly to the consumer in an immediate connection. But most of the time it goes to some kind of a gateway on the way here. So the structure again is that we have what's called a VTN, the virtual top node, that manages all the resources and everything, typically situated at the utility or ISO, or I guess a DSO in Europe, and then we have dedicated links between the different parties, and these lower end devices, the end nodes, are what we call virtual end nodes, VENs, are again gateways or cloud-based control, or any type of system that controls a load. And in the case for the presentation today, of course, a lot of them are EV charging control systems. So one thing that's important to note is that we are not talking about a networking technology here. So these devices, like the residential home and these are small medium businesses and so on, they are not by any means connected in this link. So these links are dedicated between the two peers, and the aggregator would apply a certain analysis, a certain logic, intelligence, if you will, to then control these systems. The same happens in buildings. Typically, OpenADR is not being used to turn on or turn off devices, but rather to provide information elements. And we'll talk about that a little more when we talk about these control strategies. So what is it really? A little backwards here, I guess I start with the second bullet. It's XML payloads. So pretty straightforward, fairly small messages, but we do use OASIS web services. So some of the protocol structures here are taken directly from web services standards, like WS Calendar, for instance. And the main services in OpenADR are the event service that sends and acknowledges DR events. You can imagine that very similar to a calendar notice. So if you have a calendar notice for a meeting. It has a start time and end time, and then it can have a lot of additional information inside that calendar, because you want to maybe have an agenda or a different tracks and things like that. All of that is possible at OpenADR as well. And so this is the main service that we use to communicate mostly prices and energy consumption requirements, but it could be a whole flurry of different signal types that we have in the standard. The opt service, not being used too much just yet, but it's starting more and more, basically provides availability schedules. And this can be very interesting, of course, for EV charging as well, because you might be able to communicate back to the DSO, to the utility, what is the availability, what is typically connected to your chargers at what times and things like that. So a very good option here to ahead of time provide information like that. Then the report service, I guess fairly self-explanatory. It's feedback, it's real-time feedback. It can be either just simple status messages, like we are up and running, we are ready to modify our energy usage, or it could be things like charge state, or other things like forecasts, or of course also historical reports, like what was the consumption over the last few hours, days, weeks, whatever is necessary. And the register or party service is really a very basic means of connecting the devices on a lower level here. So the communication, as I said, through broadband, sometimes through dedicated internet connections. And the key is that we use TLS 1.2 as the security mechanism, but with server and client side security certificates. So this is, for some folks a little bit new. So that is really one of the biggest points for manufacturers to keep an eye on, because that gives many of the client manufacturers the biggest problems initially until they have everything really lined up here. So we heard earlier already from Arjan and several other people about all kinds of different standards, and heard about OCPP and EBUS and so on. And the nice thing about OpenADR is that it actually really works well with any of these standards, because really you can imagine OpenADR as an informational and motivational messaging standard. So really OpenADR, as I mentioned already, we don't like to turn off things. We don't want the customer to be inconvenienced by something that they might not want to see, but we rather give the customer a choice here. So with other words, again, we send price information or requests for energy consumption changes, both up and down. And then the logic in, for instance, the charging system can then figure out, okay, where can we best make use of this, or change behavior, or change charging to accommodate these signals. So there's really no direct translation here. We often are being asked, so can we translate between OpenADR and OCPP, or OpenADR and EBUS? It's really not absolutely necessary, because we are really detaching this a little bit here. And I'll show you in a second what the difference is that I mean here. So let's then really talk about these control strategies. But to do that, let's first quickly review where we are coming from. So if you remember what I mentioned earlier, that OpenADR was conceived in the early 2000s to help with shortages in energy. Demand response was really defined as just a response to price or other incentives to avoid high electricity prices, or in fact, of course, peak situations. So peak shaving was certainly initially the main characteristic of demand response programs. But then certainly now over time, we are seeing way more systems on the other side. So generation, storage, we see microgrids or smart communities. All these things are certainly becoming more and more important. So now we are starting to see more emphasis on specific price events, on a particular power quality changes, things like that. And now it becomes the good question, okay, who is responsible for what? And how much do you want to tell the customer what to do? And so we try to kind of put this in a little slightly, even though it's not really that easy, and we call it the distributed energy resources direct management versus the distributed decision making on the other side here. So on the left hand side you have direct control, where the utility, DSO, or whoever is responsible for these systems from an overarching perspective, they would directly control these systems. So if you have large resources like large solar farms, you have grid scale batteries, things like that, it makes total sense to directly control these with the SCADA network, the control network at the utility side. So you would use standards that more directly communicate with these systems, very similar to what a utility would do with their substation, generation, and so on and so forth. So that makes the most sense here. And then on the other end of the scale, of course, you have the smaller resources, commercial, small commercial solar, residential solar, batteries, and of course also cars here and other things. And there again, the question is, and we heard that before from some of the other presenters, how much control do you want to take away from the customer, who may in fact own this equipment on the other side? And we see quite, I wouldn't call it a fight, but certainly, as we like to call it, a bit of a struggle for the DER control here, because when we talk about the customer-facing companies and people, they think more about information-based communication, similar, to what OpenADR can do. Again, inform and motivate the customer. Versus, when we look at folks that want to really keep an eye on power quality and so on, they might want to change direct inverter settings and things like that to then essentially adjust the power output of these inverters. And of course, that would come back to the customer in the end. And for electric vehicles, that certainly also means that the utility would be able to decide when to do what with these chargers and so on and so forth. So a lot of the systems, in particular in EV here, prefer a more open approach, and that leads us really to some of these case studies here. And one I wanted to show here first, this is in fact an older one. They have extended this now. I'm waiting for some updated numbers here. Southern California Edison was one of the first ones here in California. And I think it's probably fair to say that there was also one of the first ones in the US that started trials with this. And initially, they would just provide varied pricing, so time of use rates to the charge system operator. And then via OCPP, the communication would be made to the charge station directly. Now, Southern California Edison has expanded this quite a bit past these SCE facilities, which were in the initial trial, and pretty much all charging systems in Southern California are operating in a similar fashion here. We also see this now popping up in Northern California, PG&E, as well as other states, of course, Hawaii and many other areas. And so it's really starting to develop quite nicely, as utilities notice that these EV chargers are giving them the most trouble, if you will, here for their grid. Another interesting study to look at is certainly this virtual power plant project that was conducted in eastern Germany and Slovenia. And I copied the link in here for those of you that are, really into the math of all these things. It is a very, very interesting paper, very technical, I have to admit. I had trouble understanding all of it, but very scientific, but really interesting how it shows how such a virtual power plant that includes also battery charging station, vehicle to grid, and then other mechanisms here can really balance a lot of its own load out over time. So really worth the read if you're into this more scientific approach here. Another thing that recently, in fact, last year happened, and there were still a few players missing here that I think they were hoping to add, was the global grid integration project. Elaad was also a part of this, as well as a number of car makers. Last year, I believe in November, was an interoperability event where this scenario was successfully demonstrated. Again, using OpenADR from, in this case, it was a simulated utility server down to a control system. And in this instance, then EE-bus was used to actually communicate with the individual charge stations of the different car manufacturers here. The test event worked out really well, and we are waiting to see what the next steps are on this in Europe here. Along the same lines, in Hamburg, Germany, the Elbe project has been started, and there were clean air program funds available. A very similar setup, as you can see here. The slide was loaned to us by ChargePoint. OpenADR is coming from, in this case, more of a municipal utility, the Stadtwerke in Hamburg, going through a cloud-based VEN, which is connected, or which is part of the charge system provider head end here, and then they control the devices, typically also with either EE-bus or OCPP. So the next steps here are to really come up with the final implementation and start deploying this potentially in a number of different municipal utilities. Another reference architecture that you can take a look at some point is the flex charging reference architecture. Also a similar approach here. So we see quite a bit of interest popping up in that as well, and we hope that we see more activity coming up here. So I think that gets me to the end of my 15-20 minutes. So my contact is here, and I give it back to you, Frauke.
Excellent. Thank you very much, Rolf, for keeping the energy up in this final presentation of the day. Thanks a lot. I think we have another poll coming up before we go into the questions. Yes, there we go. Another check of the audience. What protocol do you have experience with? Our little market polling to get an idea of the participants' preferences.
Frauke, can I ask one question in between?
Yes, please go ahead.
Okay, hi Rolf, Arjan speaking. Hey, so what you mentioned is that OpenADR is, did I understand it well, that it is mainly an information protocol and not as much a control protocol, as it sends commands, and then you probably integrate it with another system, and that actually performs the commands towards the devices?
That is exactly correct, Arjan. Yes, and you know, that is not to say that you couldn't use OpenADR directly to a device. I mean, we have, for instance, signal types that have, let's say, a set point for a thermostat, right? So this could be, this could be seen as direct load control, as we would call it, but the actual idea behind OpenADR is to provide information. So what that does is really, it provides a really nice demarcation point, right, between, say, DSO utility and the customer, by not directly controlling and pushing, you know, controls on the customer side. Again, equipment that might not be owned by the utility, but rather by the customer. But it makes the case for the customer to react to changes in the price, to requirements or requests from the utility, and they can then really, you know, based on their own intelligence. Again, you have these cloud-based building management systems, right? You have gateways. You have, in our case here, the EV charging control systems. The operators there, they can really make the decisions that fit their business, that fit their customers, on how to respond to these information elements.
Yeah, okay, understood as well. Thank you very much. Frauke, back to you.
Thank you very much, Arjan and Rolf. And here we go, the results of our poll. 38% OCPP, and you're not doing too badly, Rolf, with OpenADR ranking number 2 together with KNX at 15% of this very selected, obviously group in our audience.
I think since I'm the presenter, I can't really see the results.
I will read them out to you.
About that.
Yeah, I will. No, now I cannot see them either. They just disappeared from the screen. Can we have them read out, Adrian? There we go. So we have 38% OCPP. That's the winner basically on what people have experience with. And then we have 15% for OpenADR and KNX. And we have 8% for eBus. And 46% haven't used any of the standard protocols so far.
Okay. So that's the experience with these protocols.
That's the experience in this audience, yes.
Excellent, super, yeah.
Good. We are coming very close to 5 o'clock. Still, if there are questions, then I would urge you to quickly post them now. So far, we have broader questions that I think are not necessarily for here, but we have a comment I can already share if you haven't followed the chat. Still responding to the previous presentation on V2G and battery health. If you're interested, a link to a fan report on V2G and battery health, possibly even being positive. But back to Rolf's presentation, I don't see any new questions coming in. Is that correct? No questions. I see. Very good. So you were extremely clear, Rolf.
I'm for happy hour, right?
Exactly. It's time for happy hour. It's 5 o'clock.
More coffee for me, I guess.
Time for coffee and a proper breakfast on your side of the world. And on that note, also a big round of applause, of course, virtually for you, Rolf, and once again for all our speakers, and in particular for you, the audience, for staying with us and remaining so engaged, asking good questions, being involved even in the virtual format of FLEXCON. And once again, a big thanks to all of those who made this event work and run so smoothly in the background. Thank you, Arjan, Mikael, Alicia, and everybody else involved. I won't try to even summarize. I think you've all heard just as well as I have all the presentations. And all I will say is, once again, the presentations will be made available to you. And we hope to see you back again in the next session next Wednesday. Be careful, the timing is different. The following sessions are going to take place in the morning. So we hope to see you fresh and curious for our next session on Wednesday. Thank you and have a nice evening.